That there, I guess we're right there. What we were looking at before, we were looking at a device, and all right, what's going on here? It seems to be complaining with me here. All right. What is my computer doing here that's not happy with? Okay. Now, we've got a device here, and it's just that there. We've got 8 inputs to it, right there. And I'm just going to call it D0, D1, all the way D7. This is our multiplexer. We have 3 lines here, S0, S1, S2, right there. And we have 1 output coming out here. I'm just going to call it Y, right there. And the idea of the multiplexer is we look at our inputs here at our select lines, S0 through S1, and I'm just going to write them. Where's our new page here? Right there, new page, right here. So we've got our lines here, S2, S1, S0. I wrote it in that direction right there. 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0. And you would think that somebody that writes 1 zeros all day long would have a lot of patience for driving schools, right? That there. If you work at 1s and 0s, you should be a very patient person. That there. So our output right here, Y, is going to be equal to D0, D1, D2, D3, D4, D5, D6, and D7 right there. So as we look at our output right there, and undo, and how do we get to the previous page right here? Right there, okay. Well, maybe I broke this thing here. Hopefully what I wrote is still there. If not, we start over again. Nope. All right, I guess I got to be careful in how I do this because getting from previous pages, I'm just going to leave this mode right here. It seems like show navigation. Okay, all right. This is where we were at, so we didn't lose it that there. So when we look at this particular one right here, that's what's selected. So when we look at what we have here, and I'm just going to draw it here. Here's Y, and we're going to take a particular, let's say D2, and that's going to be connected to that there. So what we said we were going to do is we're going to implement a 4-input Boolean function using this here. And the way that we do that is we take our normal truth table, A, B, C, D, right here. Right here. And this is the part that takes a long time when you're doing the 16, because right here. And I know that I went through this lecture before, but right there. Okay. And we're going to connect to our Boolean function right here, S2, S1, S0, and I'm going to connect A, B, C. right there. That's what we connect. Now, I'm going to go ahead and put what I want my output to be, Y, here. And I'm just going to put down random, and they're not really random because I want to make sure I hit every combination there. I'm just going to put down what I want this output to be. Now, I could do this in a random function. I'm picking a non-random function simply because I want to just show every combination out there. But the process is the same whether it's random or non-random. So I'm just going to write 1 0 1 1 0 0 0 1 1 1 0 1 1 1 1 0 right there. So that it looks like I did it randomly, but I deliberately did there. So I look at this right here, and what I'm going to do is I want to compare this to this in every two groups right there. And I'm going to circle them like this right here. It's probably the way I should have done it to begin with. I want to compare them like that there. And I want to write here what Y is in comparison to D. And it's going to be one of three things. It's either going to be 1, 0, D, or D naught right there. Those are the four choices that I have when I look at this right here. So I look at the first one. D is 0, 1, and Y is 1, 0. So that is D naught right there. The second one is Y is 1, 1. It doesn't matter what D is. So Y is 1 right there. The next one, Y is 0. The next one, Y is the same as D. The next one, it's 1. The next one, it's the same as D. The next one, it's the same as 1. The next one, it's D naught. I just do that by inspection as I walk down through that right there. So, how do we implement this in software? Now, I didn't bring a pen. Let me grab I got a pen here. Let's see if I got a piece of paper nearby that I can write on. I'm going to write on this here. I don't know. It's the manual for the board. Do I have any paper in here? Actually, someone got a sheet of paper I can steal. Let me not write on that there. In reality, I should just write it on the blackboard, but I didn't bring a whiteboard pen. That there. Okay. Just any sheet of paper, just for me to take notes. That way I don't have to go back and forth. Right there. So I'm going to write, all I'm writing down on my sheet of paper is this column right here. I'm just writing this column here down. Right there. And it's D naught, 1, 0, D, 1, D, 1, D naught, right there. So I'm just writing that down because that's what I'm going to connect these up. So with the software, let's go ahead and bring up Portis. Right there. Altera, right here. And hopefully it comes up today. Up there. All right. I could either hit a new project here at this point, which I'm going to go ahead and do that project. Right there, Portis. You may want to put these here. Design, new up there. And I'm going to call it multiplexer. Number 1, that's misspelled, but that's all right. Control C, just simply so that right there. Open. Control V. Right there. And unfortunately, I have to unplug this to hit the next button. Actually, Actually, at this point, okay, the part, as we recall, this is the Cyclone 2, and it's is it the 672C6? I believe it's already set to the right one. Let's see how good my eyes are here. Yep, that's the right part. I can actually see it today. I've got enough light on this corner. So I'm going to go ahead and hit that. Oh, it's not connected here. Right there, I selected the right part. And I'm sorry that I have to keep unplugging this. I'm just going to hit the finish button right there. But unfortunately, the resolution of the projector is such that I can't see the right there. Okay, we don't care about that. All right, so we're going to go ahead and start drawing our circuit right there. And again, and I'm going to cheat a little bit because I can't remember right off the top of my head. Is anybody going to note what the part number is for our multiplexer right there? Right there. As I recall, let me pull up the slides. Digital class. Right there. That's in the lab, chapter 6. All I want to do is remember the part number for our multiplexer. As I said, this is arithmetic. That's nope. Maybe it's okay. What happened here to my chapter 5? I keep wanting to say 138, but it's not a 138. Nope. That's chapter 4. And my battery is going dead in my mouse. Programming VHDL. Don't tell me it's clear back in chapter 3. No, it can't be in chapter 3. That's right at the beginning of the course. Maybe I'm going the other way around. Chapter 7. That's our counters. I know it's not that far down. I was thinking, now I'm really getting frustrated because I can't remember what chapter it is and I don't have the book. This is dictionary. Right there. Parallel adder, complement system. It's got to be, or I think I may have been operating on a Floyd. Well, we'll find it. All right, let me just go through here. Then we go back to the Cordis software and we will work through here. Right here. So let's go ahead and block diagram fan. And let's look for a multiplexer. See if it finds that there. Mux. Uh, 16, okay, should be listed as an 8 to, you see the problem is I don't remember the part number. That's what I get for not writing this down here. 8-1 months. All right. Okay, as it turned out, I don't need the part number. They have an 8-1 mux in the library, so we can just go ahead and stick that in there, right there. I was looking for the 74 part number that I know it was in the slides that I went through, and I was thinking it was a 138, but that doesn't sound right. So I'm just going to use that there. So as we're looking at this right here, and if you double check on this right here, this just simply shows this is the VHDL code for that particular one right there. And I'm just pulling this right up here to look at this here, and if you use the 0, generate right there, and right there. So I'm right there. I'm going to have to assume, as we look at this, that our ABC are in the order of S1, S0. The problem I've got right now is that I could have ABC reversed, but if we do, we can fix that easy enough. So what we're going to do is I'm going to go ahead and put in my 4 inputs. Right there. Now, I'm going to leave them like this right here. Actually, what I want to do is I want to put this one to the top, and I want to take these 3 here, and I want to connect them to ABC. So they're connected. This one here I left out, and what I'm going to do, and this is going to be a problem today. Hopefully I've got some AAA batteries. Right here. I'm going to bring this one down to the bottom here. Right here. And I'm going to put in here a knot. Right here. And I'm going to give myself some room here in a second here. Right here. And I can connect everything I need to a D right there. And then I also need a BCC right there. And I'm going to just place that right here. Now I'm going to rotate these around in order to give myself some more room. And then I'm going to also put, I have to use here, a ground right there. The ground is drawn in the right way, but I'm going to put it here. And I'm going to grab this one here and edit. There should be a rotate, flip, or vertical. And the reason I did that is so that as I can bring these lines up and connect them up where I need them to be. So the first one goes to D knot. So I'm just going to bring a line over here. And this is going to be very difficult. I'm sorry, but right there. And the reason it's difficult is my mouse battery is just died. Let's see if I can. Okay. Then the next one goes to a 1. Right there, there's my 1. My next one goes to a ground. Right there. My next one goes to D. My next one goes to, now I've got my 4 lines, so now I just have to bring them across. D4 goes to 1 again. Right there. D5 goes back to D. D6 goes to 1 again. And try this again. I am not good at drawing with a touchpad. I'm sorry. That there. And the last one goes to D, right? Hopefully the mouse will work long enough to get one line connected. Okay, this has to be tied to ground. So I'm just going to put a ground here. All right, almost done here. Then the last one here, we need an output. Right there. Okay. Okay. All right. There's our circuit basically right there. So there's our circuit. Let me go ahead and name these pins. Right there. Oh, and this mouse situation is. Oh, and I put D in there a second time. Right there. And then this one we said was going to be Y, right? Okay, there's our basic circuit right there. Let's go ahead and save that. Compile it. Right there. And this is taking a lot longer than I expected. Having a mouse going dead is not helping me any. I'm going to simulate it fairly quickly, and then I'm going to go ahead and assign the pins and download it, and then the rest of the time is for you to copy this right there. So, okay. Let's go ahead and create the vector waveform file. Let's simulate it. Right there. Edit. End time. I'm just going to say 5. Our grid size, 50 nanoseconds. Right there. Node finder. List. Right there. And I'm going through this quickly. Right there. Yep. Group. input. Group bit order. Most significant bit on top, that's fine. All right. Let's go ahead and hit value. Count value. Right there. Right there, that looks fine. There, let's go ahead and save it. Let's simulate it. Right there. And let's look at our output here. All right. The first two look right. The next two look right. This one looks right. All right, I think we got a problem here. Right here. And again, what our output should be 1 0 1 1 0 0 0 1 1 1 0 1 1 1 1 0 is what I got. Is that right? Is that what anybody got there? 1 0 1 1 0 0 0 1 1 1 0 1 1 1 1 0. Okay. And what do we get on our output here? We got 1 0 1 1 0 0. It looks like we got a problem here. This one looks wrong right there. Right there. Yeah. Okay, that's where I was going to go back to is when as soon as I see a problem that there, you say D7 is connected to D and it should be connected to what? D naught? That's right. Okay. And this is where I don't want to redraw all these. Okay. And D7 should be connected to D naught, right? Is what you said? Or yeah, D naught. Okay. Does that look right? Okay. Let's recompile it and resimulate it and see whether or not we get the right thing. We may have other mistakes. I'm going to save the mouse until... All right, let's see if it's looking right now, because that there. So now we're at 1 0 1 1. Should be 3 zeros. All right, it looks like there's a problem here earlier than that. Let's go back and look at my circuit here. Right there. D0 should be connected to D naught. D1 should be connected to VCC. D2 should be connected to ground. D3 should be connected to D, but it's connected to D naught. See that? Right here, as I look here, this is D0, D1, D2, D3 should be connected to D, and it's connected to D naught. Right there. So I need to delete that and connect it down here to D. Wait, that is D. It was connected to D. Yeah. So okay. Now D4 should be connected to BCC, which it is. D5 should be connected to D0. Is that right? D4, D5 I show connected to D, which it is. Okay. And D6 should be connected to BCC, and D7 should be connected to D0. It looks right, doesn't it? D0 should be connected to D0. D1 should be connected to BCC. D2 should be connected to ground. D3 should be connected to D, right there, which it is. Yeah, right there. D should be D3, D5, which it is. BCC, and why are we getting the wrong thing here? BCC should be D1, D4, and D6. Yep. D0 should be D0 and D1. Everything looks right according to that right there. Let's go back to my simulation. Maybe I'm reading the simulation wrong. Right here. This should be D. Let's just look at them in groups of two here. This is D. This is BCC. This group of two should be ground. This group of two shows right there 6 and 7 shows BCC. Yeah, that's D4. D5 is also showing, that's 8, 1, 0, 0, 1, 0, 0, 1, right there. All right, there's a problem here with input number 4. Number 4 is connected to, it shows it's being connected to BCC. 4 should be connected to BCC. That's right, okay. B3, or no, D3 looks like there's a problem. All right, yeah, this is BCC. 6 and 7. 6 and 7 is okay. Six and 7 right there. That is number 3. 3 should be connected to D. What is number 3 connected to? 3 is connected to D. That's right. 4 is connected. Why is it not working right? Someone see what I'm doing wrong here. I'm right there. Because here I'm showing 4 ones in a row, and I don't have a 4. I got three ones in a row here. D5 should be connected to D. And my alarm just went off, telling me it's time for this class. That there. There. Well, actually, it's that I'm late. But there. All right, I've got a problem here somewhere here. As we go all the way to F, F is D0. That's fine. E and D. Group these in here. This should be. You know, our problem very well could be, to be honest with you, I'm starting to see problems here. Let me change this to C. And change this one to A. I'm starting to see problems that there. And remember what I said, I wasn't sure which one was most significant, which one was least significant. So let me try this once more. since I'm not getting the right answers, it could be my guess was wrong. This is going to take us all of our 2 hours just to go through this, because now you guys have to do it. You're good. Hopefully you don't take as long as I do, since I found all the mistakes here. And my mouse not working. This is not even a Monday morning. Okay, this actually looks more correct to me, to be honest with you, looking at this right here. Because as I look at the output here, I'm seeing 1 0, 1 1, 3 zeros, 3 ones, a 0, 3 ones, what, right there, this is right, I've got, should be 3 ones in a row, I've got a problem here. I'm not going to fight through it, but this one looks much more correct, is that I probably do have a problem someplace back there. I'm not going to dig through it. At this point, I'm going to just go ahead and download to the board this particular one. Back there. So while I'm looking for the pin numbers, go ahead and start drawing this part here. You guys go ahead and draw this circuit right here. So I'll go ahead and you guys get started, and I'm going to go ahead and look up the pin numbers for my 4 switches, and I'll add that there. So there's no point you waiting for me, especially since I've got to File Explorer, desktop, and I need to find here, I should have on my desktop where is my DE2? Oh no, if anything can go wrong, I just got another glitch here, is that my audio, my battery is just now going low. Right there. Let me change. I'm going to stop this recording. Recording will be in 2 parts. Okay, I found the data sheet for the pins right there, and I was looking for the LED right there, and the LED X. There should be LED red right there. I'm just going to use that one right there. LED red 0. That is going to be AE23. Y is AE23. Okay. Now let's go back to my circuit and assign my pins. Right there, and I will write those up here in a minute here. All right, assignments, device. Remember that we need to set our unused pins to input tri-stated. Then I've got to do this because it won't let me do that. My pins and location A, I just said was AE14. B is P25. C is N26. D is N25. And Y is AE23. Right there, those are my pins. You might want to get those down there. Recompile. And if we don't get this done today, we will finish it on, we meet again Thursday, right? Yeah. Wednesday is the holiday, so that doesn't affect this class. I am so confused in life right now. I hate to admit that. I was arguing with my class last night that they wouldn't be meeting on Wednesday, and then they kept saying we don't meet any Wednesday. They don't meet on Wednesday, and all of a sudden it dawned on me that class meets on Monday and Tuesday. It's my other class that meets on Tuesday or on Wednesday, on Tuesday and Wednesday. I'm so used to classes that meet Monday, Wednesday, or Tuesday, Thursday, and here they have classes that meet Monday, Tuesday, or Wednesday, Thursday. So the scheduling is different than what I'm used to. And I ran across that the first time yesterday. So let me grab my pen, my cable, wherever there's a cable here. Oh, there's my cable. And I am going to try to program this board, and hopefully it works. Right here. Right there. And the programmer. And start. And our program, okay, it's programmed. Now let's look. I'm going to go back to the simulation, and I'm going to flip the switches and see whether or not it matches the simulation here. Right there. Right now my switches are all off, and my LED is on. Now I'm going to turn on 1, the LED goes off. If I go to 3, the LED comes on. If I go to 4, the LED goes off again, and 4 should be off. 5, it's on. 6, it's off. 7, it's on. 8, it is on. 9, it is on. A is off, which it should be off. Okay, that's fine. When I go to B, it's on. Now if I go to D, it's on, which matches the simulation. I go to E, it's on. And if I go to F, it should go off. So my board is matching my simulation. Right there. So everything's working on my end here. Now what do you need? You still need this circuit right here, right? And actually, if I right there, and actually right there, and you can get your pin numbers off this right here. So now let's see how much you remember from last time. That's there. So when I'm going to kind of go around here at this point. I'm going to stop the recording because there's no point in recording at this point because